Hello all, I'm Srijana and I'm going to teach three subjects in this semester, that is computer network, formal languages and automata theory, and one program elective, that is graph theory. All three subjects are very important, and from this video we are going to start with computer network. Syllabus of computer network I had already shared with you all, and that is having 4 units. In the first unit, we are going to discuss the basics of data communication and the features of physical layer and the data link layer. In second unit, we will be discussing about the various protocols of the network layer and various routing protocols. In Unit 3, we will be discussing about the various transport layer protocols. In Unit 4, we will see some of the important application layer protocols and the security features of computer network. Regarding books, there are two textbooks that we are going to refer, and most of the topics we will be covering from this second textbook, that is Data Communication and Networking by Beros A. Furausen. And some of the topics we will also be covering from first textbook, that is Computer Networks by Tenenbaum. And I've already shared the PDF of the second book with you all. I'll be sharing the PDF of this first book very soon. These are the references. You will be getting the study materials online also. And during my video, if you do not understand any of the topic, then you can always refer the online study materials also. And I'll be sharing the other study materials with you all. Okay. So let us start. As I already said, computer network is very important subject for computer science engineer, and during the course you will be able to understand how this different topics of computer network is useful for you, and most of the competitive examination also has huge portion of the syllabus from the computer network. Okay. So what exactly is computer network? If I have to define in the simplest term, then computer network is nothing but the collection of device that will be connected by some type of transmission media and that are capable of communicating with each other. Okay, so those device can be computer or it can be some other device also. Okay, so that is called networking and internetworking device. So a device which is capable of sending and receiving information can be connected by transmission media, which can be wired or wireless, and once the connection is done, once they agree to some set of rules, they will be able to communicate with each other. Okay, so communicate with each other is nothing but they will be able to share the information or the data with each other. So before understanding the various features of computer network, we need to know some of the basic terms. So, and those are, what exactly is data? So data is nothing but the information that the device will be communicating with each other. So the information has to be presented in some form, okay, which the other party should be able to understand. So that information which is in the presentable form, which can be understood by the other party, that is called data. And the main objective of computer network is data communication, that is to exchange the data between two devices by using in between we are going to use the transmission media. Now the requirement of computer network is not only to share the information from one device to another device. Okay, user is going to accept that network only if it satisfies this following criteria. These are called effectiveness of data communication, and these criteria are, you can see here, delivery, accuracy, timeliness and jitter. Okay, so that means a network has to satisfy this criteria to be acceptable. Now the first criteria, delivery, says that every time when a device is sending a data, that data will be for some destination, and once the data is transmitted through the network, it has to be delivered to the correct destination. Okay, let us say the destination is A, and due to some fault in the computer network, the network is delivering that data to some another node, so that is not acceptable. So delivery means every time a data is sent, it has to be delivered to the correct destination, okay, not to the other nodes. Accuracy says that whatever data was exactly produced by the sender, the same data has to be delivered to the destination. That means in between, the unintended user should not be allowed to change or modify the data. Okay, so data has to be exactly same copy of which it was sent by the sender. The receiver should be getting the correct data, okay, not the altered one. Timeliness says that the data, once it is sent to the computer network, it has to deliver to the correct destination as per the delivery requirement, and it should not be altered during the transmission. And the timeliness requirement is it should be delivered within some predetermined time. Okay, network should not take some infinite amount of time to deliver the data. The last one is very important, that is mainly applicable to the multimedia data. Multimedia means audio or the video, that is jitter. Okay, suppose let us take an example of video. Whenever a device is sending video, it is actually sending series of frames, okay, where each frame is considered as one data. Okay, now between each frame, here as I said that video is going to contain the series of frame, and between each frame there will be some predetermined time. Okay, so let me discuss this with an example. Okay, so let us say that we are sending a video, and as I said that video is going to have series of frames. So let us say these are the different frames. This is first frame, second frame, third frame, fourth frame, fifth frame, and so on. Okay, and for the video quality to be good, the delay between each successive frame will be fixed, has to be fixed. Okay, that is, let us say the delay that in my example I am taking is, let us say, 3 millisecond. Okay, which means that for the video quality to be very good, the delay between every frame has to be exactly 3 millisecond. Okay, now suppose if due to the delay in the computer network, if the delay between the first two frame is 3 millisecond, whereas the delay between the second two frame is, let us say, it became 5 millisecond. The delay between third and the fourth frame, let us say, it became 2 millisecond. Okay, so because of the problem with the computer network, here you can see that the delay between the successive frame is different. Okay, this is called jitter. There is variation in the delay between the successive frames. Okay, and the requirement from the computer network is whatever delay between the successive frame was set by the sender, the network should try its best to deliver all the frames with that predefined delay. Okay, so that is, I hope the jitter is clear to all. So jitter refers to variation in the packet arrival time. So if there is uneven delay, like in this example, if there is uneven delay, then we say that there is jitter. Okay, so the video is suffering from the problem of jitter. Okay, so moving ahead, the various component of the data communication systems are message, sender, transmission medium, and the protocol. So these are the basic things which we need to know before starting the computer network. And as I said that the basic requirement of computer network is to share the data. Data is nothing but the information or the message that the other party can understand. So in the computer network, a message will be communicated between the devices, and those devices will be sender and the receiver. Sender is the one which is sending that message, and receiver is the one which is receiving the message. And the message will go through a transmission media that can be wired or the wireless. If it is wired, then the message will have to travel within that media or the cable, and if it is wireless, then the message can follow any path. Okay, so there will be air in between, so it can follow any path to reach the destination. And the last one is very important, that is protocol. Protocol is just connecting two devices is not sufficient. Okay, you need to connect the two devices that should be capable of communicating with each other, as well as those two devices should have a protocol installed in that. Okay, so protocol is nothing but the set of rules that both the device is going to follow. Okay, let us say sender is sending a data that is being represented in ASCII format, but receiver is using, let us say, some other format like Unicode. Then if sender is sending A, then receiver is going to decode that as B. Okay, which will be incorrect. So that means sender and the receiver, they will have to follow some agreed protocol or agreed set of rules. Then only whatever they are communicating, the other party will be able to understand. So these are the important components of data communication, that is message, sender, receiver, transmission medium, and the protocol. Okay, so this data can be of following types. Data can be text, okay, which can be represented in some coding format like ASCII or Unicode. Unicode is very much popular nowadays. And data can be number also, that will be directly represented by bit patterns. Data can be image also. Now how that image will be represented is, actually the image will also be represented by as bit pattern, but that representation will come after representing an image as a matrix of pixels. Okay, so image will be considered as a matrix of pixel, and in each pixel, if it is 1, that means light. If it is 0, then it is off. Now audio is cannot be represented by discrete value, it will be represented by continuous value. And video, it can be continuous or it can be discrete. Okay, continuous, like for example TV. Okay, whatever video that you get, that is a continuous stream of data. And suppose if you are recording some video by mobile phone, that is a discrete representation of video. Okay, wherein the entire video will be represented as a sequence of frames. Now, what are the different types of communication that can take place between two devices are, this is represented as data flow. It can be simplex type of communication, half duplex type of communication, or it can be full duplex. Okay, so between two devices, if the direction of communication is only in one direction, that is if it is possible to send data from one device to another device only, okay, not from the other device back to the first one, then it is called simplex communication. You can see here that is, we have this device which is sending some data to this device, but it is not capable of sending the data to this one. So this type of communication is simplex. For example, let us say keyboard. From keyboard you are typing something, and that is going to generate the data, and that data will be given to the processor. Okay, so the communication between keyboard and the processor is unidirectional. The data can only be sent from keyboard to processor, but not back from processor to keyboard. So this type of communication or the transmission mode is called simplex. The second type of transmission mode is half duplex, wherein you can transmit data in both direction, but only one direction will be active at a time. Okay, for example, you can see here these two devices are connected, and both the device, they can send and as well as they can receive, but when one device is sending the data, the other device will not be able to transmit. So other device will have to wait until the data communication from the first device does not end. Okay, so once data communication from this device to this one ends, then only the second device will be allowed to transmit. So this is called half duplex. And the third type of transmission mode is called full duplex, wherein both the device, they will be able to communicate simultaneously with each other in both the direction. So they are going to have two dedicated line. Okay, wherein if one device is sending, the other device will be able to receive, as well as the other device can also send. Okay, so this is called full duplex type of communication. So example, as I already said, for simplex, for example, from processor to monitor. Okay, whatever processor will be generating, that data can be communicated to the monitor and you will be able to see, but monitor cannot generate the data and send to the processor. Okay, so the type of transmission media that will be used is a simplex type of transmission media. Now, the example of half duplex is walkie-talkie. For example, in case of walkie-talkie, if one is talking, the other will not be able to talk. The other person will have to wait until the first person does not finish. Okay, and the full duplex communication is most of the network. Okay, all the network in the computer network, they support the full duplex communication, wherein there will be two different paths. Okay, dedicated for each the communication in each direction. Okay. Now, as I already said, network is nothing but the collection of devices that will be connected by the transmission media, and each device that I said is also referred as a node. Okay, so we are going to use this term frequently in this subject, that is a node. So node is nothing but something which is capable of sending as well as receiving the data. Okay, now in case of this bit. So if you are given with some set of network and you have to decide on which network is better, then how you are going to do that? Okay, so that can be done by checking how efficiently the various network criteria are being satisfied. Okay, so the different network criteria are performance, reliability, and security. So the various performance measurements are transit time, response time, throughput, and delay. Okay, so transit time is nothing but the amount of time that the message is going to take to travel from one node to another node. Response time is, suppose if I have sent some query to my network and how much time the network is taking, okay, to give me the response. So that is called response time. Throughput means what is the amount of data that my network is capable of carrying simultaneously. Okay, so that quantity of the data can be represented either in terms of bits, okay, or that is the number of bits, or it can be represented in terms of number of signals. Okay, that is called frequency. Now the last performance criteria is delay. That is the amount of time that is required to transfer a data from one network to another network. Okay, so these are the various performance criteria. Then the next network criteria is reliability. Reliability means if there is some failure, okay, then whether the network is capable of locating that failure and recovering from that failure or not. Okay, so that is how much robust a network is. So if there is any fault that has happened in the network should be able to identify that fault, recover from that failure. Okay, and it should not be affecting the users who are currently using the features of the network. Now the third network criteria is security. Security is very important nowadays. You might have heard about a cyber security subject which is getting very much popularity and importance even in India. And security means the network, in the network large amount of data communication continuously takes place, isn't it? And simultaneously you will find large number of unauthorized user called hacker. Okay, they may try to read your data, they may try to modify your data, or they may try to be false sender. Okay, so they like you may have identification problem also in the network, so these are related to the security. So wherein some your data is being hacked, okay, or your data is being changed, damaged by some unauthorized user. So how your network is dealing those type of security problems, so that is a network criteria which must be looked upon by the network engineer, and that needs to be solved. Now we are going to see the various types of in the various ways in which we can connect the different devices by using the transmission media. So this type of connection can be either point to point or multi-point. So point to point means when we have direct link between the sender and the receiver. Okay, so that means the two nodes are connected with each other by a dedicated link. So that means link here is nothing but the transmission media, and between these two devices, this link is going to carry their information. So this link is not going to be shared by any other devices. Okay, so point to point will be very much secure, and it is going to give you very good throughput. So because there will not be any kind of interference, so data communication will be very fast. Okay, and it will be very secure. The second type of communication connection, that is the way in which we can connect the different devices, can be multi-point. That is, you can see here you have one transmission media that is being shared by multiple devices. Okay, so the data that will be communicated through this link, that suppose this node is sending a data to this node, then it is going through this two intermediate node. Okay, so it is very much vulnerable to security threat, and as well as all the node, they will have to coordinate with each other for the communication, because if two nodes simultaneously transmit their data, then their data may collide and it may get damaged. Okay, and also because large number of data is going communication is going to take place, so it may be slow. So this type of connection is a multi-point connection. So based on these types of connection, we have different types of topology. Topology means all the devices of the network, how they are connected to each other. Okay, so there are two types of topology. One is physical and the other one is logical. Physical means how all the devices are physically connected with each other, okay, by using the transmission media. Logical means how the different devices are going to communicate with each other. Okay, physically they may have been connected by some way, but logically they are communicating in some other way, so this can happen. So topology means how the different devices are, all the devices of the network, they are connected with each other. Okay, now various types of physical topology we will be discussing here, and those are there are four basic types of physical topology. One is mesh, star, bus, ring, and there is one more type of physical topology called hybrid. Hybrid is nothing but the combination of these four basic types of physical topology. Okay. So next we are going to see each type of topology one by one. So we will be starting with the first one, that is mesh topology. Topology, as I already said, how all the devices of the network are connected with each other. Okay. In case of mesh topology, there will be dedicated link, that is a point-to-point link between every devices. For example, you can see here there are 5 devices, and between all 5 devices you have a direct transmission media, a dedicated transmission media. So this is a mesh topology. Okay, so suppose if this device want to send some data to this one, it can directly send. It need not be sending via some other devices. Okay, because there is a direct link from this device to this device. So that is, between any two device, you have a dedicated link, so they can directly communicate with each other. Okay, now in this type of mesh topology, as the name suggests, it is messy. Large number of transmission media will be required. Now the next important thing for us to see that if we have n number of devices, then how many transmission media or how many port that is used to connect the transmission media with the device will be required. So let us see that thing. Now suppose if you have only one device, okay, let us try to find out how many, for given n number of devices, how many transmission media and how many port you will be requiring. Okay, suppose if you have one device, then how many transmission media you will be requiring? 0, isn't it? Because it is only one device, it need not be connected to any other node. And how many port you will be requiring? The port is a device that is used to connect the transmission media with the device. Okay, so how many port you need? Port also you will be requiring 0. Now suppose if you have, let us say, two devices. For example, this is the first one and this is the second one. Then how many transmission media you will be requiring? To connect these two devices, you need one transmission media. So that is your 1. And how many port you require? 1 in this side to connect this transmission media with this device, 1 in the other side, that is to connect this transmission media with this side. So you will be requiring 2 port. Okay, suppose if you have 3 devices, now to connect these 3 devices, how many transmission media that you will be requiring? 1 to connect these 2 devices, the other to connect these 2 devices, and the third one to connect these 2 devices. So how many transmission media you needed? 3. Now in that case, how many port in total that you will be requiring? 2 for this device, 2 for this device, and 2 for this device. So for each device, the number of port that will be required is 2. For this device, it is 2. Let me rub this one. For the port, let us only talk about with respect to each device. Okay, now let's say that with respect to this device, with respect to each device, here the number of port that will be required is 1. Okay, here the number of port that is required is 0. Here the number of port that is required for each device, okay, that it needs is 2. Now suppose if I increase the number of node, that is if I made this number of node to 4 or number of device to 4, then how many transmission media that will be needed to connect? You need to have a direct connection between every pair of devices. Parallelly, you try to draw in your copy also. Okay, so that means it is going to require 1, 2, 3, 4, 5, 6. So 6 number of transmission media is required, and each node is going to need 3 number of port. Okay, so that is, there will be 3 cable that will be connected to each node. So each node will be connected to 3 other node. Now similarly, if I increase this number of node to 5, then as we had seen in the PPT, that there are 5 node, and how many cable that we are requiring here? 1, 2, 3, 4. So 5, 6, 7, 8, 9, and 10. Okay, so total number of cables that we need is 10. So that is, if we have 5 node, then the number of cable that we will be requiring is 10. So, and the number of port for each cable that we will be requiring is 1, 2, 3, 4. Okay, 4. So let us go back to this one. So number of port that will be required is 4. Now, can you relate, if you have n number of node, then how many transmission media that you need to have to connect it in a mesh topology, and how many port that you will be requiring? So if you have only one node, then 0 transmission media. If you have 2 node, then 1 cable is required. If you have 3 node, then 3 cable is required. If you have 4 node, then you need 6. If you have 5 node, then you need 10. So what is the relation that is going on here? So the relation that is going on here for the number of transmission media is n into n minus 1 divided by 2. So you try to figure it out. So this is nothing but, let us say, if you have 5 number of node, or 5 number of devices, so 5 into 5 minus 1, that is nothing but the 4 divided by 2, and its value will be 5 into 4, 20 divided by 2, that is equals to 10. So you can see here, if the number of node is 5, then you'll be requiring the 10 number of transmission media. And how many port that you'll be requiring? If you have 5 node, then it is number of node minus 1. That many port is required. So here if you have 5 node, then you need 4 ports. So you have 5 node, that means 4. Which means that if you have n number of node, then you'll be requiring n minus 1 number of ports. Okay. This type of topology comes with various advantages. Like you have a dedicated link between every two device, okay, which means that that link is going to carry the information of those two devices only. Okay, so there will not be any traffic problem, so the delivery will be very fast. Okay, and the second one is, suppose since you have the data that is going to travel through that link only, so if there is any other unauthorized person, they will not be able to get your data, okay, or they will not be able to alter your data. So that is secure. It is robust also. That is, for example, if you are not able to communicate, there are so many other paths. Okay, so suppose if this device is not able to send to this one, then this can send to some other device, and which can forward it to the other device, because there is a link between every device, and there will be a path for communication between any two device. Okay, if one path fails, then you'll be getting the another path. The next very important advantage of mesh topology is, if there is any fault or the failure occurs in this type of network, then it will be very easy to identify, okay, by the network administrator. That is, suppose for example, if this link has failed, then these two devices will not be able to communicate. Okay, so the network engineer will be able to identify it, and they will be able to resolve it. But this mesh topology, even though it has lot of very good advantages, but it comes with lot of disadvantages also. And that is, because it is a mesh topology, and you are connecting every two device directly, you need large number of cables, and to connect that cable with your device, you need large number of ports. Okay, as we had seen previously, that the number of cable that you'll be requiring is n into n minus 1 by 2. But if that cable is capable of carrying data only in one direction, then to transfer data in the other direction, you need one more cable. Okay, so that means between every two device, you need to have two cable. If that cable can support only the half duplex communication. Okay, so in that case, the number of cable that you'll be requiring is n into n minus 1. Okay, double of what duplex type of cable will be requiring. Now, another disadvantage is, since you need to connect every two device, its installation will be very difficult. Okay, and if you need to reconfigure it, if you need to change something, then it is very complex network, so you'll be having difficulty. The next is obvious, it is very expensive, and since every device needs to be connected with each other, and you need to have a dedicated link, so it is going to cost you a lot. Okay, so these are the disadvantages of mesh topology. The next topology, which has tried to overcome lot of disadvantages of mesh topology, is star topology. So in case of star topology, there will be a central device called the central controller, and all other device, they will have dedicated link only with that central device, okay, or the hub. So you can see here, there are four devices, and four devices, they are not directly connected to each other. Okay, but they are connected directly to the central controller. Now, if one device wants to send some data to the other device, then that device will be sending data to the central controller, which is going to forward that data to the other device. Okay, now it also has some good advantages and comes with some of the disadvantages. And the advantage is, if you compare this topology with mesh topology, it is less expensive, obviously, because the number of cable for n number of device will be only n, and the number of port for each device required is only for that one cable, that is only one port. Okay. Also, it is robust. Okay, if there is a fault, then it can be easily detected. Now, its disadvantage is you have the entire network relies on only one central controller. Okay, that is a hub. If the central controller fails, then the devices will not be able to communicate at all. Okay. Second disadvantage is since all the communication, data communication is taking place through the central controller, now there will be a lot of traffic at this point. Okay, now the central controller will have to manage those data and will have to forward the data to the respective destination, and it may take some more time, okay, in comparison to mesh topology. The next type of topology, which is different from mesh and the star, is bus topology. Here, instead of dedicated or the point-to-point link, you have the multi-point configuration. Okay, that means all the devices, they will be connected to one transmission media. Okay, so one cable will be shared by all the devices. So you can see here you have a cable. So this cable is called backbone cable, and all the devices, they are connected to this backbone cable by a drop line. Okay, by a cable called drop line, and this cable will be connected to backbone cable by using a tap. Okay, and all the device, they will be sending their data through this cable. Okay, so when one device is sending, the other device will have to wait, because that since that device is sending, so uh, that device will be occupying the. Okay, and this is one type of communication. In another type of communication, this is called time shared. Okay, wherein like so in time shared, as I said that when one device is sending, the other all other device will have to wait. So they will be allowed to send only in their. Another one is frequency shared, wherein the frequency of the cable can be divided, and all the node, they will be able to communicate simultaneously, but they will be getting the less frequency. And at the end of this backbone cable, you can see here there will be a terminator. Okay, this cable end is called terminator, and this terminator is a device which is capable of observing the signals. Okay, suppose if this node is sending data to some another node, so this node will be sending data to the backbone cable, which will go in both the direction. Okay, now data that is going in this direction will be consumed by the destination, but the data which is traveling in this direction has to be consumed by something, otherwise it will reflect back to the same cable, and that is going to cause noise. Okay, that is going to occupy the frequency of the cable. So there has to be a terminator here that is going to consume the signal. Now, its advantage, you can see here, it is very easy to install because you have only one cable that will be connected by all the devices. Okay, the number of cables that will be required is very less. Now, the problem here is since only one cable is carrying data of many devices, okay, so there will be a limitation on how many devices you can connect and what should be the gap between each successive device, because when the signal will travel, it will be generating the heat. Okay, now because of heat, the amount of power that the signal contains will keep on reducing. Okay, and after some time the signal will fade. So to deal with this problem, the number of device that will be connected to the cable and the gap between each successive device will be decided. And the disadvantage with this one is during once you have installed this type of network, and in between if you want to add some device, then it will be very difficult because you need to reconfigure everything. Another disadvantage is if there is any fault in this type of network, then it is very difficult to identify where exactly the fault has occurred, because a small crack at one point is going to disrupt the entire communication in the entire cable. Okay, but still this bus topology is very famous. It is actually mainly used in a backbone network. Okay, in internet also, to connect the different network, bus topology is used. The next type of basic topology is ring topology. Here you can see here all the devices, they are connected in form of ring. Okay, so they will be communicating with each other via its neighbor node. Okay, now the communication can be unidirectional or bidirectional. Unidirectional means the communication can take place only in one direction. Bidirection means communication can take place in both the direction. Like for example, if this node want to send the data to this one, if it was unidirectional and direction was towards this side, that the node will have to send the data to this node, and the data will have to travel all the way from different node, and finally it will be able to reach the destination. Suppose if it is a bidirectional ring topology, then this node can directly send to this node. Okay, so its advantage is, you can see here, it is very easy to install. Okay, it is very easy to add new device also, because you only have to just disconnect this line and connect the other two node. Now its disadvantage is, because in the ring all the device, they need to communicate following this ring pattern, the time that will be required for communication will be very large. Okay, suppose this need, there are, let us say, 1000 node in my ring topology, and communication, average communication time that will be taken between two node will be very high in comparison to other type of topology. So that is why ring topology is not very famous. Okay, mainly because of constraint related to time. And the last type of topology is hybrid topology, wherein we can connect the different type of topology to form one topology. Like for example, here the star topology is used to connect the three different types of topology or the network, that is bus, ring and star. Okay, so this is called hybrid topology. Oh, sorry that the PPT was off for this duration. Okay, whatever I said was this one, that is mesh topology. Okay, wherein you have the dedicated link between the devices. This is your star topology. You have a dedicated link only with the central node. Okay, and this is your star topology advantages and disadvantages. Bus topology and ring topology, and this is your hybrid topology. Okay, so next we are going to see the different types of network. So broadly, based on the size, based on who is the owner of that network, how much distance that the network has covered, okay, how the network has been laid out physically. There are three different types of network. One is local area network, metropolitan area network, and wide area network. So local area network is that network which usually covers very small area, like which can be less than 2 miles. Okay, yeah, it is a network wherein the devices are connected within a small area. Okay, which can be one building or which can be one campus. Like SIST is also installing local area network. So within that SIST building, all the computers will be connected via a network. So that is a local area network. Now the owner of local area network will be usually private. Okay, so private, it will be privately owned. Like the owner of local area network of SIST will be the SIST only. Now the second one is metropolitan area network, which is bit bigger network in comparison to local area network. So it is going to mainly cover like one entire city. For example, you have the cable network. Okay, network by the cable, TV cable, you can say, that covers one entire city. So that type of network is called metropolitan area network. Like if you want to get a broadband connection by BSNL or by some other provider, then that comes under metropolitan area network. So the owner of metropolitan area network can be a private, some private user, or it can be by the group of user, or it can be government. The third one is wide area network. As the name suggests, it is a network that covers the entire world. Okay, so that covers a large geographical area. For example, internet. So internet is a example of wide area network. Okay, now internet, the owner of internet there are so many, there are group of people, okay, whoever is connected to the internet, so that the person can use, so that internet is publicly owned. Now there can be some wide area network which will be privately owned, like for example by Reliance and all. So that type of network which covers a very large geographical area and which is privately owned, that is called enterprise network. Okay. Now the next one is, as we were discussing previously, that in computer network connecting two device is not sufficient. Okay, just having transmission media and the two device which are capable of communication is not sufficient. That is not going to make those two devices communicate. You also need to have software to be installed in both the device. Okay, and what that software which will be installed in both the device will be doing is, it is going to follow the set of rules for the communication. Okay, so the message that the user will be generating will be changed by the software. It is going to take, the software is going to take that message, and the software is going to make some changes in the message, and then finally the message will be sent in form of signal via the transmission media towards the destination in the network. Okay, so the important term in the network is what is protocol and what is standard. Okay, so protocol is nothing but the set of rules, okay, that will be implemented by the software that will be installed in each device. Okay, and that set of rule is very important for two devices to communicate with each other, because as I said previously, that if one device is sending text message which is represented in ASCII form, and the other device is reading in, let us say, Unicode coding format, then they will not be able to understand anything from the message. So that set of rule which governs the data communication, which is called protocol, is one very important thing. And this protocol is going to define what will be communicated through the network, and how that communication is going to take place, when the data is to be communicated. So everything will be governed by the protocol. Standard is the set of protocols is called a standard. Now this protocol is going to have the three key element, that is syntax, semantics and timing. Okay, now when the sender is sending a data, that data is going to have various subsections. Okay, and the syntax means how each information will be encoded. Okay, how each information will be presented, that is nothing but the structure or the format of data. Okay, let us say the data has four sections. First section is going to contain the address of the receiver. Second subsection is going to contain the address of sender. Third subsection, let us say, some security related information, and the fourth subsection is, let us say, the actual data. Now this structure is will be made by the protocol. Now in this structure, that is in the syntax, what is the meaning of each subsection, okay, and how each bit pattern will be interpreted, okay, by the network and by the destination, that will be governed by the semantic. And timing means, timing has two feature. Okay, one is when data needs to be sent, okay, and how fast the data needs to be communicated by the network. Okay, now this is important because the different device, their speed may not be same. Let us say, for example, sender is generating data with speed of 100 mbps, but receiver is able to receive or process the data with the speed of only 1 mbps. Okay, then 100 mbps data going to the receiver will not be able to process. Okay, so that means the receiver will not be able to accept the remaining 99 bits, okay, in each second, you can say. So how this will be controlled is by using the timing feature of the protocol. Now, as I said, that this set of protocols is called standard, and there are various standards that has been given by the various organizations. Okay, that has been identified by the various organizations, and those organization which decides on the standards are in computer network field also. Those are ISO, ITUT, NC, IEEE, and EIA. So this is it for today's class. And if you have any doubt, okay, in any of the topic, please write to me. I will explain it again, okay? Or if you want some other materials, then I can provide you. So see you in the next class.